Okay, hello students. This lesson is about arithmetic sequences, and in it we are going to identify arithmetic sequences, use the formula to find the nth term of the sequence, and also find the sum of an arithmetic sequence. So first of all, an arithmetic sequence is defined as a sequence where there is a common difference between consecutive terms. So arithmetic sequence means that there's a common difference between the terms. So let's see if we can identify which of the following sequences are arithmetic. And if they are arithmetic, we'll see if we can find the common difference. Okay, when we look at this sequence, how much, it looks like the numbers are going up. Okay, they're going up from -3 to -1, then from -1 to 1, and from 1 to 3. If we subtract these, we can see that each time it's going up by 2. So since it's going up by 2, yes, this sequence is arithmetic, and the common difference is 2. How about here? How much is the sequence going down between 15.5 and 14? It looks like it went down 1.5. Okay, so now going from 14 to 12.5, how much did it go down? Subtracting these two numbers, we can see again it went down 1.5. So it looks like this sequence is also arithmetic, and that the common difference is negative. It's going down 1.5. So notice that in order to find the common difference, what I'm doing is subtracting two terms. Okay, so let's see about this one. Going from 84 to 80, it looks like 84 minus 80 gives us 4. It went down 4. And then going from 80 to 74, there it goes down 6. So it looks like it's not going down by the same amount each time. So no, this sequence is not arithmetic. How about this one? Going from, okay, I see it's going from -8 to +6, and then from positive back down to negative. So it looks like it's oscillating between positive and negative. First it had to add numbers, then it had to subtract numbers. So it's jumping around. So that sequence is not going to be arithmetic. Okay, and then lastly, looking at this one, it goes from -50 to -44, then from -44 to -38. So how much is it going down? -50 to -44. Looks like we added 6 there, and then -44 minus -38 is again 6. So our common difference is 6. Okay, so that is how you can identify whether or not a sequence is arithmetic. So let's see. The first terms of an arithmetic sequence is A. We call that A. Then we add D, the common difference, to get to the next term. There is a pattern, and therefore there is a formula that we can use to give any term that we need without listing the whole sequence. So here is the formula for the nth term of an arithmetic sequence. The nth term of an arithmetic sequence is given by this formula. So the A of n, A sub n is the last term of the sequence, or in many cases it's going to be the term that we're looking for is an. Okay, I already said up here that A, just A by itself, that's the first term in the sequence. Sometimes they'll say A sub 1 here to be the first term of the sequence. Then this n here, this n is the same as the n. This n is the same as the n that we're talking about here, and it tells you the number, the position of the number in the sequence. So is it the first number? Is it the second number? That's what this n is telling you. And then D is the common difference. So let's look at an example of this. So let's say that we're given a sequence like this, and that the question to us is to find A of 32. Okay, so first of all, what does that mean? A of 32. That means that they want us to find the 32nd term in the sequence. So the first term here is 79, and the next term is 75, the second term, the third term is 71. But what is the 35th or 32nd term way out here? That's what they want us to find. So when we look at the sequence, let's just go ahead and identify things that we know. We can see the first term is 79. And how much is it going down each time? From 79 to 75, it looks like it's going down by 4 each time. So the common difference, D, is going to be 4. Then we can also identify which term we're looking for. We're looking for the 32, so the N is going to be 32. So again, A1, the first term is 79. The common difference is going down 4 each time, and we're looking for the 32nd term. So now, in order to solve this, we just need to plug into our formula the things that we were just saying. So we have the formula here. Okay, we're just going to plug in the various things that we just identified into the formula. Substitute N to be 32, A1 79, the difference to be -4, and we solve and we get -45 for the answer. So just plug in. Okay, let's say that we're given a sequence, but instead of asking what's the 35th term in the sequence, let's say that they give us that term. The term is -169, and I'm asking you to tell me what term number, how many numbers in the sequence out do we have to go before we get to -169. So again, we need to identify the things that we can about the function, about the sequence. We can see the first term in the sequence is 79. Okay, and we know it's going down by -4 just like before, but this time we know that A of N, the number that we're looking for, is -169. So again, we're going to plug into the formula. Okay, this time we have a value over here, the 169, to plug in, but what we don't know is in the position of this number in the sequence. Okay, so we're going to plug in and we're going to solve as we would normally solve an equation by like subtracting the 179 to the other side, dividing by -4, adding 1. We get 63 for N. So that means that -169 is the 63rd term in the sequence. Okay, we also can find the sum of terms. So arithmetic series is the sum. An arithmetic series is the sum of the terms in an arithmetic sequence. So a sequence is like what we just had a second ago, where the values, the terms are separated by a comma. See how they're all separated by a comma? That's a sequence. Well, a series is when all of those things are added together, the sum of terms. So this is a series where they're added, and a sequence when we have commas. Now we can find the sum of the terms of an arithmetic sequence by using this formula. I like to think of this, I like to remember this formula by remembering that it's kind of like the average. You add the first and the last together and divide by 2. That's the average of the first and the last terms. And then we have to multiply by the number of terms in the sequence. So you find the average and you multiply by the number of terms. So in this formula, S means sum. Then N is the number of terms. A1 is the first term and AN is the last term. Okay, let's look at an example of using this and see if we can find the sum of the series. Find the sum of the series for this arithmetic sequence. Okay, so here's our sequence. It starts at 51 and goes down to 47, 43. Okay, and we're going to continue this sequence all the way down till we get to -5. So it looks like we're subtracting 4 from each of these values, right? It's going down by 4 each time. And what do you have if you add up all the things in the sequence going down to -5? Now you could continue the sequence out and add them up yourself, right? So you could just subtract 4 again and say the next term would be plus 135 and then plus 131 and then continue adding them all up yourself, but that's going to take you forever. It would be much easier if we use this formula. So in order to use a formula, we need to figure out what term is the -5. Okay, so first thing, because in order to use this formula we have to plug in n, and we don't know what n is. That's the problem here first. So we're going to figure out what n is by using the other formula that we already know. Okay, we're going to use this formula, and when we plug in the common difference to be -4 going down by 4, the first term is 151, and that an is -5, we find out that -5 is the 40th term in the sequence. So now that we know that -5 is the 40th term in the sequence, we can go ahead and use our formula, using n to be 40, a1 to be 151, and then a40 to be -5. Okay, we plug into the formula for sum of a series, and the sum of all those is 2,920. Okay, we can also do this. We can also find the sum of an arithmetic sequence if we are given this, if it looks like this. Okay, when we have this e here is summation. Okay, the e means summation, and it's telling us to add. The numbers above and below the e tell you what numbers to plug in for the variable. That should be plug in for the variable. So this is telling us that we're going to plug in 1 for k, and then we're going to continue plugging in until we get to 35. So we're going to plug in 1 for k, then we're going to plug in 2 for k, then we're going to plug in 3 for k, 4 for k, all the way up to 35. So we're going to substitute n for k one at a time all the way to 35, and then we're going to add them all together. So when we substitute in 1 for k, we're going to have 29 minus 3 times 1, which is 26. Then we plug in 2 for k, and we get 23. We plug in 3 for k, we get -20, and you can start to see the pattern, right? It's subtracting 3 each time. Okay, so we plug in 4 for k, plug in 5 for k. You have to keep going all the way until you plug in 35 for k, which is 76. Okay, and because it has this e here, that means we're adding all these together. So we're adding the 26, -26, plus -23, plus -20, plus -17, all the way to 76. So, now we can find the sum of the series using our other formula. So, find the sum of the arithmetic series. Here's the same formula we were just using, and we plugged in numbers, and we saw that this formula gives us this sequence, or sorry, this series. It's a series, right, because they're added together. So in this series, we can see that n, the number that we're trying to add to, is 35, and that the first number in the sequence is -26, and that n of 35, when you plug in 35, you get 76. So we're going to use the formula, and we're going to plug in. Okay, and we have -36 plus the first term plus the last term plus 76 divided by 2, and then times 35. And the sum of the series is 875. All right, so class, you need to make sure that you have those two formulas written down, as well as the examples of how to use them for tomorrow in class. Great job.